The word radioactivity may be short, but it is deeply profound. Countless lives in Japan paid the price to truly understand its power. The tragic events in Hiroshima and Nagasaki stand as stark reminders, not merely as historical events, but as enduring sorrows. This series delves into the origins, growth, and evolution of this fearsome phenomenon. The journey began in 1895 with Wilhelm Röntgen's discovery of X-rays, followed by Henri Becquerel's accidental findings and the groundbreaking research of Marie and Pierre Curie. Their work not only led to the discovery of new elements, but also laid the foundation for modern nuclear science. Welcome to the physics frontier, where we explore the origins, evolution. Let's begin. In 1895, the German scientist Wilhelm Röntgen witnessed something astonishing. While experimenting with cathode rays, he stumbled upon a new kind of ray, one that could pass through solid objects to a certain extent. To prove this, Röntgen used these mysterious rays to capture an image of the bones in his own hand. This discovery created a global sensation when Röntgen sent these photographs to renowned scientists worldwide. Since he was uncertain about the nature of these rays, he named them X-rays. Within just 3 weeks, medical colleges began using X-rays to examine and repair broken bones. The news of Röntgen's discovery reached French scientist Henri Becquerel, who was working on a phenomenon called phosphorescence. Phosphorescence refers to the property of certain materials to absorb sunlight and emit it later in the dark. Becquerel was intrigued. Could this glow be related to X-rays? Driven by curiosity, Becquerel conducted an experiment. He exposed a phosphorescent compound, potassium uranyl sulfate, to sunlight all day. Then, he wrapped it in black paper and placed it over a photographic plate to see if the compound emitted rays similar to Röntgen's X-rays. When he developed the plate, he found it had darkened as he had expected. But then came an unexpected twist. On a cloudy day, without sufficient sunlight, Becquerel set aside his experiment and stored the setup in a closed drawer. A week later, when sunlight returned, he reopened the setup to check if the photographic plate was still intact. To his surprise, the plate had darkened significantly, even though it had been in a pitch-dark drawer the entire time. This surprising observation revealed that potassium uranyl sulfate could emit rays spontaneously without absorbing any sunlight. By accident, Becquerel had stumbled upon something monumental. This was the first step toward the discovery of radioactivity. For the next several months, Becquerel meticulously studied these spontaneous natural rays. He observed that they could heat objects and even make dry air electrically conductive. Using an electroscope, he measured the intensity of these rays. Despite his progress, Becquerel couldn't fully unravel the mystery and would have to wait 2 more years for a breakthrough. Meanwhile, Becquerel's research caught the attention of a young Polish scientist named Marie Curie, who was searching for a topic for her doctoral thesis. Intrigued by his findings, Marie posed a critical question. Is radioactivity a property of compounds or an intrinsic property of specific elements? Marie began experimenting with various uranium compounds. She discovered that the amount of radioactivity depended solely on the amount of uranium present in the compound. The more uranium, the greater the radioactivity. From this, she concluded that radioactivity was an inherent property of the element uranium itself, not its compounds. But Marie Curie didn't stop there. She asked yet another question. Are there other elements apart from uranium that exhibit radioactive properties? Marie expanded her research to include other elements. Her persistence paid off when she discovered that the element thorium was also naturally radioactive. Marie's work was progressing well, but she encountered a puzzling challenge when she began studying a mineral called pitchblende. She noticed that the radioactivity of pitchblende was millions of times stronger than that of uranium and thorium combined. This led Marie to a bold hypothesis. Pitchblende must contain some unknown radioactive element with far greater radioactivity than uranium or thorium. At this crucial juncture, her husband, Pierre Curie, joined her efforts. Together, Marie and Pierre Curie embarked on the painstaking task of isolating this mysterious radioactive element. After years of grueling effort, they succeeded not just in discovering one element, but two. They named these elements radium and polonium. Both were incredibly radioactive. They also noted that radium's chemical properties resembled those of barium, while polonium's resembled those of bismuth. However, a major challenge remained: isolating sufficient quantities of these elements to accurately determine their atomic weights. Since pitchblende contained only trace amounts of radium and polonium, they needed large amounts of the mineral, which was prohibitively expensive. The solution lay in acquiring discarded pitchblende residues. At the time, some companies extracted uranium and thorium from pitchblende and discarded the rest as waste. Marie and Pierre suspected that these residues still contained radium and polonium. The couple worked tirelessly, processing nearly 1 kilogram of pitchblende each day. They separated barium and bismuth from the residues, then painstakingly isolated radium and polonium. After 4 years of relentless effort, they processed 8 tons of pitchblende to extract just a few milligrams of radium. From this tiny sample, they determined the atomic weights of radium and polonium. This groundbreaking work earned Marie Curie, Pierre Curie, and Henri Becquerel the Nobel Prize in Physics in 1903. Their discovery not only unveiled new elements, but also laid the foundation for nuclear physics. This scientific breakthrough had far-reaching implications, revolutionizing fields like medicine and igniting an unprecedented wave of progress in human history. From a simple accident to a scientific revolution, radioactivity changed the world forever. But how was the proton discovered, and what are the fundamental laws of radioactivity? We'll explore that in the next video. Stay curious and keep exploring with Physics Frontier.